Okay, so today we're going to look at some questions from the Module 2 Lesson 3 problem set. This lesson is called Understanding Addition of Integers. It's just a sort of continuation from Lessons 1 and 2. But the main idea is predicting where the sum of two integers will be based on the change that's happening. If you're being told that the number line, there's going to be a certain leftward movement or a certain rightward movement on the number line, or something is rising or falling by a certain amount, finding where that sum is going to be. So this first question with this table, I recognize as super important because I think there was a test question in previous years that looked just like this. So this is a good question to be really focused on. It says below is a table showing the change in temperature from morning to afternoon for 1 week. So each one of these rows represents a day. 1 day, 2, 3, 4, 5, 6, 7 days. Use the vertical number line to help you complete the table. As an example, the first row is completed for you. So I don't think we need to actually draw anything on this number line. It's just here for us to reference. So the first day is done for us. It says that in the morning, the temperature was 1 degree Celsius. And then the temperature change was a rise of 3 degrees. And so we can represent that with the equation 1 plus 3 equals 4. So the afternoon temperature was 4 degrees. So I like to do the equations first, and then I write the afternoon temperature over here. So in the second day, the morning temperature was 2 degrees, and it rose 8 degrees, so I add 8. And that equals 10. So the afternoon temperature was 10 degrees Celsius. Next, it says in the morning, the temperature was negative 2 degrees Celsius. And there was a fall of 6 degrees during the day. And so I can represent that by adding negative 6 to represent that fall. And if I have negative 2 plus negative 6, well, if I'm already at negative 2, and then I fall 6 more, 1, 2, 3, 4, 5, 6, I get to negative 8. So negative 8 is my answer. Okay, so we started at negative 4, we rose 7, so it's going to be negative 4 plus 7, and I know that that equals positive 3. And if you weren't sure about that, you could just start here at negative 4, and then count up 7, and you should get to 3. Okay, so we have a morning temperature of 6 and a fall of 9 degrees. So that's 6 plus negative 9 degrees. Notice I'm doing everything as plus negative. I'm not representing the falls with just minus 9 because these whole lessons are about the addition of integers. We'll get into subtraction soon. So if I started at positive 6 here and I fell 9, I'm pretty sure I would get to negative 3. So the answer on this one's negative 3. I'm going to let you finish out the rest of that table. So question B says, do you agree or disagree with the following statement? A rise of negative 7 degrees means a fall of positive 7 degrees. Explain. And note, no one would ever say a rise of negative 7 degrees. However, mathematically speaking, it is an equivalent phrase. So, I mean, they're kind of telling you the answer right there, right? Do you agree or disagree with the following statement? But then in the note says a rise of 7 degrees, or I'm sorry, a rise of negative 7 degrees is an equivalent phrase to a fall of 7 degrees. So, yeah, I agree. I agree that they're equivalent. It's kind of weird to say it, but yeah, they're equivalent. 2. Terry selected 2 cards, so we're talking about the integer game. The sum of her cards is negative 10. Can both cards be positive? Explain why or why not. I can't think of any way that I could be on a number line and start with a positive position, like a positive card, and then add more positive to it and somehow arrive at negative 10. So my answer would be no. And the explanation would be something like, there's no way you could add 2 positive values and get a negative sum. B, can one of the cards be positive and the other be negative? Explain why or why not. Sure. I mean, I could think of lots of pairs of a negative number and a positive number that would add up to negative 10. And if we're thinking about the integer game itself, I'm pretty sure the lowest card you can have on there is negative 12. I'll draw a little card. And I could have the positive 2 card, and that would equal negative 10. So sure, I could have one positive, one negative. And then C says, can both cards be negative? Explain why or why not. Well, sure. I could have like the negative 6 card, and I will let you figure out what card would have to go with that to make negative 10 if I used negative 6. Okay, so now let's look at these questions over here. It says, number 3, when playing the integer game, the first 2 cards you selected were negative 8 and negative 10. What is the value of your hand? So if I'm in a number line and I'm already at negative 8, and then I need to go 10 more negative from there, so I'm moving to the left on a number line. Oh, I have one right here. I don't know how well you're going to be able to see this. Okay, so I'm at negative 8, and I move back 10 more spaces to the left because it's negative 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am at negative 18. So the value of my hand right now is negative 18. It says justify your answer. I don't know, I just did with that counting. But I'm just going to write negative 8 plus negative 10 equals negative 18. For part A, what is the distance of the sum from negative 8? Okay, so they want to know how far away is negative 18, which is the sum, from when we started, negative 8. And you saw me count 10 spaces to the left. So that's the answer they want. It's the distance is 10, and I'll just write that it's to the left. That's the way we moved on the number line to get from negative 8 to negative 18. And it says, if you discarded the negative 10 and then selected a positive 10, what would be the value of your hand? So this is going to move my hand way in the positive direction, because just getting rid of the negative 10, well, that's going to get me back to negative 8 where I was, because I had a negative 8 card and a negative 10 card. And then if I picked up a 10, I would have to add that to the negative 8. And so I'd have negative 8 plus 10. I'm not even going to worry about the negative 10 anymore because they just said I discarded it, so it's not in my hand anymore. And this equals, well, just to be sure, if I'm at negative 8 and I count 10 spaces to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I am at positive 2. It says write an equation to justify your answer. There it is. There's your equation. Number 4, given the expression 67 plus negative 35, can you determine, without finding the sum, the distance between 67 and the sum? So yeah, I know that the sum, whatever this answer is going to be 35 spaces away from 67, and it'll be to the left of 67 because I'm adding a negative number. So I'm just going to write distance 35 and comma to the left. So this is just kind of all about knowing where to look for a sum on the number line. Like being able to say, okay, if I'm adding negative 35 and I want to figure out what this equals and I can't do it in my head, I'm going to use a number line. Okay, I know I got to go 35 units to the left. All right, number 5. Use the information given below to write an equation. Then create an arrow diagram of this equation on the number line provided below. Okay, I'm not going to do the, I like to call them vectors. I'm not going to do the vector diagram for you because we've done those so many times in class and I think you're all pretty good at it. So instead, I'll help with the equation. It says the sum of negative 4 and a number is 12 units to the right of negative 4 on the number line. Okay, so I'm starting at negative 4, and then the answer that I need is 12 units to the right. Well, the only way I could build an equation that's going to lead me 12 units to the right from negative 4 is by adding positive 12. And then I have to figure out what that sum would be. Well, if I started at negative 4 and I added 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I get to positive 8. All right. There's your lesson 3 problem set.